All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are, I don't know, we're just gonna be doing a bit of a yap sesh because I got a chance to stream. I haven't streamed in, I don't know, 3 4 days. Dude, I'm doing a horrible job of trying to stream daily because what I had decided at the beginning of the year was, hey, throughout this year, I want to try and stream a lot more, and I want to do my talking streams, but in addition to that, I also want to do my data science lab streams. Basically, I want to do my mute streams where I'm doing, whatever else, and that just doesn't seem to be happening. I'm still trying to do that. I'm still gonna try because, dude, I mean, okay, if I'm not able to do my talking stream, then at the very least, I want to do my data science lab stream. So that way, not only am I getting more of my data science studies done, but I'm also streaming more. It's just that, dude, holy shit, I keep getting busy with stuff. I keep getting distracted with stuff. My latest distraction from what was already a distraction, which was Git. My latest distraction is Rust. So Rust is one of those things that I've been learning it on and off whenever I get the chance, and gradually, through learning it on and off, and eventually doing like practical projects with it and stuff, I have gotten better at it, and I've gotten a little more experience with it. There's still tons and tons that I need to learn. There's still various Rust related concepts that I need to both familiarize myself with, but also practice more so I actually remember them. Stuff like using cell and ref cell and other similar types. Stuff like using the dyn keyword, and like in what situations I would find that helpful. Stuff like that. And I also need to actually start doing things with Rust. And the great thing about Rust is that there's a massive community centered around Rust, and there's so many different crates for various different things. So like, if you can think of something that you want to do, there's a decent chance there's going to be a crate out there made in Rust, or there's a crate out there that allows you to do that with Rust. So just to list a few things, just broad categories, uh, it would be graphics and audio and game development, and of course ML and embedded programming, deep learning, and a bunch of different. I think there might be something for I'm not sure what word to use, cybersecurity or infosec, or because like both cybersecurity and infosec, they're kind of broad terms. But yeah, you do have, I'm pretty sure you have crates for those purposes as well, or for the various subfields within them. I'm not sure what to say. Anyways, you get the point. There's a lot that you can do with Rust, and I keep looking for excuses to use Rust. That's why I want to try and do projects in Rust so that I get better at it. My latest thing in the past, my thing was that I wanted to use Rust to do Win32 API stuff. That didn't really happen because once I started doing that, I realized that I need to learn how to do unsafe coding in Rust. And I still want to learn how to do unsafe coding. It's just that I never managed to go all the way with that. Like, I never managed to see it all the way through, I guess is what I should be saying. I started doing research on unsafe stuff. Mainly, okay, so with unsafe stuff, mainly what I wanted to do research on and understand better was pointers in unsafe Rust. And then I would be able to jump into Win32 programming for with Rust. Because I did start it, but then I realized that certain things that I was trying to do, they required the unsafe context. So I was like, okay, let me do research and uh, learn how to do unsafe coding in Rust first, and then I can carry on with it. And then I just ended up getting distracted, and I didn't do it. Well, anyways, now my latest uh, interest, I guess I should say, my latest interest, let's say, in Rust is, or rather, the latest thing that I've chosen to occupy myself with in Rust is there were two things. Oh yeah, embedded programming, more specifically ESP32 programming in Rust, and ML in Rust. So ML, when I say ML, I mean ML, data science, and deep learning. I want to I want to kind of focus on these two things because I figured that trying to do ESP32 stuff in Rust is a very good way for me to also practice Rust more, because I've done MicroPython stuff in Rust, no, in ESP32. I've done MicroPython. I've been using MicroPython to program ESP32s. So I already know the basics around that. I'm familiar with the tool chain and the various things that you need to set up in order to get that going, and it's great. It's amazing. There's a lot of libraries out there for various things, for various like modules and stuff, different types of displays, different drivers and stuff like that. There's a bunch of code already available. I'm hoping that that is the case with Rust as well. Either way, I do wanna move forward with doing ESP32 programming with Rust. There's still a bunch of research that I have to do, and I've started doing that research, and that's on okay. So that's on the embedded programming side. On the ML side, I decided to revisit this framework that I'd found a while back called Candle. There was another one, I think it's called Burn, and I think that framework does ML stuff as well. But I decided to stick with Candle. One of the reasons is, this is going to sound silly, but one of the reasons is because it's made by Hugging Face. So I was like, maybe it might be, maybe somehow it might tie into other Hugging Face stuff that I'm doing. It might make things a little bit easier. Like, for example, I don't know. Um, I don't even know what good example to give, but I've been learning I've been learning, just as an example, I've been learning how to use Hugging Face transformers, and I've been learning deep learning, right? I was like, okay, maybe what if I start learning Candle, and I'm eventually able to tie both of those things in, even in Rust, through Candle. And it kind of seems like I can do that because I looked at some of the code examples. I still have lots of exploring to do in this, and I'm kind of excited to do that because doing this in Rust is going to make it so I'm practicing not only Rust but also deep learning. I still have lots more exploration to do, and definitely tons and tons of practicing to do. Fortunately, they have a bunch of examples. I don't remember where the examples section was, but they have a lot of examples. They also have a lot of like sub modules, I guess I should call them. But yeah, I'm hoping whatever knowledge I've gained from learning about Hugging Face transformers, maybe that might tie into this, and who knows, maybe I might be able to mix the transformers on the Python side to the transformers on the Candle side or on the Rust side. But yeah, yeah. Regardless, I'm excited to get into doing ML stuff, or well, DL stuff, deep learning stuff in Rust through Candle. So I'm currently focusing on. Actually, there's a bunch of different things that I'm focusing on in Rust. You know what? I wrote down this list yesterday. I really don't want. Uh, how do I say this? I really don't want Rust to kind of take over everything that I'm doing, because there is a bunch of other stuff that I need to be doing. So I don't want it to completely take over everything. However, I do want to give it a fair amount of time. That being said, give me a second. Let me open up this notebook that I had. Okay. All right. Give it a second. I was about to say give me a second, but no, wait for this notebook to do its thing. Uh, what is this? A code cell or a markdown cell? Okay, either way. Cool. So, Rust. Give me a second. There. So, Rust. The first thing I'm trying to do, I still don't know how to pronounce this, so I'm just gonna say Saturday because that's what I've been saying from the beginning. Oh, you know what? Let me Google it. Let me let me Google it right now. Or let me try asking Llama. I'm learning how to use the Saturday library or crate in Rust. I'm wondering uh, how how is the name meant to be pronounced? It's pronounced as Sir D. Sir D. Okay. Um. Okay. I didn't. Wait. Really? Give me a second. Somebody else is saying, "Oh, dude. Okay. Hold up. Hold up. Hold up. I just remembered this. Okay. Um. I think somebody who was hanging out in somebody who was hanging out in my stream a while back when I was doing Rust programming. They had, I think they had brought up CRD. Because okay, somebody here mentioned that it's supposed to be pronounced CRD, as in serialization and deserialization, and I just remembered that I think that person had also brought this up when I'd asked how is it meant to be pronounced, and they mentioned it's CRD, which stands for serialization and deserial. I don't know if it actually stands for that, but like I think that's how they picked the name. Um, give me a second. I'm looking. Okay, serialization, deserialization. So CRD. Give me a second. I'm still okay. Suggestions on how to say this. Okay, so there's Sir, there's Sir D, there's Sir Day, there's Sir Day, which I think that's what I was saying initially. Uh, Not D or Seer, especially not so and so. Okay, all right. Give, give me give me a second. I'm just reading something. I'm just hold on. Give me a second. I use Sear and D. Okay. After using Sear D for the longest time, only now have I realized that the name comes from serialization and deserialization. Sear D. You know what? Okay. Okay, so we're gonna call it Sear D. Great. So Sear D JSON. Then give me a second. Let me open this up. Okay, the next thing I wanted to focus on was networking. Not focus, but like I just want to get an idea of how to go about doing it. More specifically, socket programming, not high level stuff. I just want to do socket programming. I'm gonna start with UDP, maybe touch TCP, and then I'm done with the networking side. Of course, I also want to look at unsafe coding, more specifically pointers, but they have an entire page for unsafe coding stuff. So I'm just going to go through that. I'm going to read it and at least get the basics down. Another thing I wanted to look into was multi-threading, and this is probably the first time that I'm going to be looking into multi-threading exclusively. I was about to say explicitly, but I don't. Well, yeah, explicitly. This is the first time that I'm going to be looking into multi-threading in, I think, any programming language for that matter, because I haven't done it. Like, I just haven't done it. Like, I've explored a bunch of different programming languages over the years, and I've been programming for more than I've been doing C sharp and Python for more than a decade, and in both of them, I've mainly avoided multi-threading as much as I could. Mostly because I didn't usually need it, but if I would have learned it, then I'm pretty sure I would have found uses for it. I just never, I just never learned it. I think I touched it in some of those languages, a little bit, like a tiny bit, but I never really went too deep into it. Okay, the next one is Tokyo. In Tokyo, okay, so I want to explore the Tokyo library to learn how to do async stuff, but also how to do multi-threading stuff. Because okay, a while back I had mentioned that I wanted to create a Python script that's gonna a Python script for doing backups of my projects and stuff. So basically, it would crawl through a bunch of directories that I mentioned, or it'll crawl through all the subdirectories in a root directory that I mentioned. And in there, it's gonna not only is it gonna copy those directories, but it's gonna crawl through them and try and figure out which directories are Unity projects. And if any of the directories are Unity projects, it'll kind of list them down and or note them down, I guess I should say. It'll make note of them. And when it's copying those directories, it's going to exclusively exclude certain folders based on patterns that I give it. So this is something that I want to this is something that I want to set up in the program. Like that's going to be the complex part of the program. One is recognizing folders, and this is I feel like this is going to be something that makes the script or makes the program a little more special, or a little more sophisticated, I should say. It's not the fact that it's just copying folders; it's recognizing specific folders, and then based on what it recognizes, I can specify a rule set that, hey, ignore this or do that, stuff like that. I can come up with something interesting there. Initially, I was going to do it in Python, but now I'm wondering if I should kind of challenge myself and do it in Rust instead. Because it'll be, I'm pretty sure there's going to be challenges there. I don't know. I'm still deciding because like if I do it in Rust, I 100% want to do I 100% want to make it multi-threaded. If I do it in Rust, then if I'm gonna do it in Python, then I'm probably just gonna stick with you know the regular Python stuff. And at most, I might make it async, but I'm not really gonna touch multi-threading there. The thing is, if I did it in Python, it would there wouldn't be nearly as much figuring out to do, if that makes sense. And I'm incredibly comfortable with using Python. Not so much with Rust. Rust is still a new language for me, so like it's going to be one of those things where like I'll be figuring out a lot of stuff as I go along. So I need to decide if I want to work on this program in Rust or in Python. I was initially planning on doing it in Python, but then I decided to do it in Rust just so I can get some practice of Rust. But now I'm wondering if trying to do it in Rust is just gonna, how do I say this? I'm wondering if trying to do it in Rust is just gonna make things a little more harder than they need to be. Because I mean, if I do it in Rust, there's a bunch of different advantages. Like, so I definitely plan on posting this program online, whether it's a Rust program or a Python script. I plan on posting it online regardless. Um, one difference. I mean, there's going to be a bunch of different differences. But one difference I can say for sure is that with Rust, it's not, you won't need to have Python installed. You won't need to have something installed beforehand because it's going to be a binary. Like it's going to compile, it's a program. It's going to compile into a binary, right? The entire code is going to compile into a binary, a program that you can run. You don't need to install something separately. Whereas with the Python script, um, usually you're running the script using a Python interpreter. You can like set up that there is a package. I think there's multiple packages, but there is at least one package that allows you to create like a um I don't even know what to call it, like a self-contained binary kind of thing. No, not a self. No, I don't know if it's a self-contained binary, but there is something that allows you to produce an exe file that can be run directly without having to install anything. So you can then pass that over to whoever wants just a program that they can run, and then they can run that exe, and all of the other Python stuff gets handled automatically without them needing to install Python exclusively. I'm not planning on doing that. If I do, if I do write the program in Python, I'm not planning on setting up that whole thing, mostly because I don't need to. Because every single system that I have, um, it has Python on it by default. I mean, okay, every single Linux system that I have, it has Python by default. And the only Windows system that I'm running right now, which is the one that I'm streaming off of, I usually install Python on it. Like if it's going to be a Windows system and I'm using it for any kind of programming, Python is definitely going to be a part of that. So I'm going to install Python anyways. So I do have Python installed here as well. Uh, but yeah, dude, I don't know. I don't know. I kind of want to challenge myself and do it in Rust. Not only do I want to do the program in Rust, I also want to try and make it multi-threaded just to see just to see just to see how, what am I trying to say here? I don't know, just to see how well I'm able to do it, how performant I'm able to make it. Because if I do it in Python, it's just going to be like a sequential program. I'm going to set it up for running, and it's going to run. It's going to take as long as it takes, and that's that. I'm not going to be, um how do I say this? How do I say this? I'm not going to be, what was I even trying to say? Shit, I lost my train of thought. Okay, anyways, um yeah, if I'm writing the thing in Rust, then I'm going to make it multi-threaded just so I can see how performant I can make it. If I'm writing it in Python, that's what I was saying. If I'm writing it in Python, it's going to be sequential. Um, at most, I'll try to make it async, but I'm going to have to do some research on, because okay, this specific program is going to be, it's going to be focusing heavily on file IO. It's not necessarily CPU intensive work. So I need to see how I can improve the speed of a program that is CPU intensive. No, that is file IO intensive. And from what I've understood, apparently for file IO stuff, depending on what you're doing, multi-threading can make things a little more a little faster. But then it depends how you go about doing it. Yeah, yeah, definitely definitely depends how you go about doing it, because with multi-threading there is also this thing called context switching that happens. And the if the load that you're trying to if the load that you're trying to offload onto another thread is not heavy enough, then you're not really going to see any performance gains from offloading the work to a different thread. On the contrary, if the load is like super light, then you're basically wasting resources, because you have to do the context switching, and then you might actually see a reduction in speed. You might actually see not even performance gains, but performance losses, because you're unnecessarily offloading work onto another thread that doesn't really need to be offloaded. Now, to combat that problem, I could try. So, okay, this is going to be interesting, because there's a bunch of different things that I need to think about with dude, you know what? No. Okay, hold on. So, something that I need to definitely consider, because I tried listing the directories in Rust, just any directories, just for the sake of an words. Holy shit! Just for the sake of an example, I tried to list just any directories, and there were certain things. I mean, it's possible to do it, but there are certain things to keep in mind when you're doing it. There's also the fact that string related stuff can get kind of messy in Rust. That's just the way it is in Rust. I mean, there's ways to do it properly. Like, I'm not saying that it's horrible at doing it. It's just that it's way less messier in Python, if I'm being honest. Because I've done it in Python plenty of times. I've also done file IO in Python. Uh, it's just much faster, and the API is also much more concise. I guess I should say that the code would be much more concise, and it would be the code the logic. How do I even say it? The code would be much more concise. It'll be less wordy. It'll be less messy. With Rust, it's definitely going to become messy. So I don't know. I don't know. I have to see how I want to go about doing this. If I want to see, I'm gonna have to see whether Python is the right choice for this or Rust is the right choice, because one of the main reasons is because like file and directory paths are involved. I mean, dude, to be fair, I could still do it in Rust. It's still possible to do it. It's just I wonder if it's going to become a bit of a headache having to deal with, because like dude, string related stuff in Python is it's amazing. It is just super easy to do. It is not messy at all. It is there are so many different functions for string manipulation. So if you're dealing with file paths, there's so much that you can do there, and there's a lot of different convenience functions. Rust has these things to a certain extent as well. It's just that Rust is not the best at doing string stuff. I don't even know how to say like I mean okay, it could just be because I'm not experienced enough in Rust, but based on okay, you know what? In the next let's say 10 seconds there's going to be an ad playing. So I'm going to start the ad break right now and I'll see you guys in 30 seconds. Okay, welcome back. So, what was I saying? Yeah, I think I was saying that Rust is not the best choice if you're going to be doing a bunch of string related stuff. Now, okay, this could also just be because I'm not very experienced with Rust, but like with the little research that I've done, um, I've found out that while it is possible to do string related stuff with Rust, you are much better off using some other language, or, well, in my case, Python. Like if I was choosing between Python and Rust for doing whatever string related stuff, and again, this is keeping in mind that I have a decade's worth of experience in Python and barely any experience in Rust. Keeping that in mind, it seems to me like doing string stuff in Python is so much better, so much easier than doing it in Rust. Okay, you know what? Let's do something here. Uh, I forgot what I was asking this LLM. Let's see what question. Okay, pandas, seaborn. Oh, I think I was asking it something about visualization because I'd found out that pandas does have. So okay, I in each of these different libraries, Python and scikit-learn and all, I'd seen visualization related APIs. But I was like, okay, maybe these are just like convenience functions for doing simple stuff. Apparently not. There's certain stuff that Matplotlib doesn't provide out of the box that these libraries do provide because they do a bunch of the work. So in the case of scikit-learn, it could be something data science related. In the case of pandas, it's something data frame related, so it makes it easier to visualize data frames directly. It also does stuff like filling in empty values, and I guess that's data. I don't know, sanitization or pre-processing. It does a bunch of that work for you and makes it easier for you to visualize data. Either way, that's one of the reasons why I was looking into whether when I should be using Panda's visualization API versus Seaborn. And I think in this case, I realized that I mean, okay, so each of them has their own use cases. I believe scikit-learn also has some visualization API, so does Pandas. And I was like, okay, between scikit-learn's visualization API and Seaborn, which one would be the better choice? To be honest, it seems like Seaborn is the better choice. And also, I feel like now that I'm doing the data science lab thing, you know what? Okay, fuck it. We're gonna do the data science lab today, after this stream. This stream, I wasn't planning on doing it for too long, mostly because I cannot. So the short amount of time that I did have, I wanted to just stream in that time. What was I saying? Yeah. So I'm going to be doing a data science stream today, a data science lab stream today. And I want to involve Seaborn into it as well, because I realized that I never went forward with Seaborn. Like, I think I dedicated one, maybe two streams to doing Seaborn, and then I was like, you know what? I'm going to come back to this. And then I just never came back to it because I kept getting distracted with a bunch of other stuff. Okay, okay. Anyways, uh let's try asking the question. Let me describe the problem. I have no, I'm creating. I'm creating a file, or no, I'm creating a program. I'm creating a script that's gonna heavily involve file IO. I should probably also mention Python. I'm creating a Python script that's gonna heavily involve file IO. I'm wondering if either async or multi-threading could speed things up in the script. Also, what are my options for both of these? Because there's a bunch of different things that I've seen. There's stuff that Python allows out of the box for both multi-threading and async programming, but I remember there also being one or two libraries that provide you with APIs for doing either async or multi-threading stuff in a much more, I don't know what word to use there, in a much more user-friendly manner. And apparently using those libraries to do your multi-threading stuff, or I think it was async stuff, I still don't remember, would be much better than using the APIs provided out of the box. I never touched either of them, so I don't remember. I actually, no, I did touch async stuff in Python out of the box. And that was simple. That wasn't very hard to set up. I mean, there was some more complex stuff in there that I had never really dove too deep into because I didn't need to. I was mainly trying to learn async programming and how to set up an async how to set up async functions and what the async workflow was like. And it was pretty simple. It wasn't complicated at all, like at all. The thing is with async is async. It's not multi-threading. Async means you're setting up asynchronous code that allows you to it allows you to remain within that same thread, but within that same thread you can kind of uh, how do I even say this? What's a good way to say this? You can set up different actions to take place, and once you've begun the action, right, you can then kind of like jump out of there and go back into your main calling code and just continue your program in that way. And then once that action completes, it's going to automatically jump back into that point in the program and execute whatever you need to, and then it's going to jump back to where you were before it jumped back. So because of this, you're able to use this to essentially create non-blocking operations, because stuff like socket programming and file IO and stuff like that, there will be a lot of times where you find these things to be blocking operations. And what that means is it blocks the main thread while this operation completes. And this isn't necessarily always a good thing, because when the thread gets blocked, it just looks like the program froze, especially if the thread is being blocked for a long period of time. Like, for example, if you have a socket that's waiting to receive some data, and if it's a blocking operation, then it's just going to be stuck there. It looks like it's stuck. It looks like the program is frozen. It's not. It's a blocking operation, so it has blocked the main thread. And then once your data comes in that you're waiting for, then it's gonna release the thread, or it's gonna unblock, I guess, because then the operation completes, right? So this is one of the places where async can be helpful because it allows you to start all of these different operations, especially if you're talking about anything IO related, not something that's necessarily CPU intensive, not something like if your CPU needed to do a bunch of calculations, like that's a different scenario, that's a different situation. In that situation, you definitely want to consider offloading that work onto a different thread. But in situations where you're IO bound, not necessarily CPU bound. So if you're doing file IO or network IO or something, that isn't necessarily CPU bound. That is more, it depends on your hardware and how quickly the hardware finishes doing that work. And in the meantime, you don't really want your main thread to be stuck. You don't want the main thread to be blocked. So you make the operation asynchronous. You start the operation, and then you continue whatever work you were doing. And once that operation finishes, then it's going to automatically jump back to that point where that operation was. It's going to jump back into the, let's call it the operate. I'm not sure how to explain this without explaining exactly how async stuff is supposed to work. So the way that async stuff works is, um, let me demonstrate it here. So you have your let's say main function, right? In your main function, you can, and let's say you have another function here, which is some kind of async function. Okay, now let's say in your main function you have called the async function. So you started the work that so let's say it does some work. Okay, in the main function you call this async function, and in here it starts doing whatever async work it was supposed to do. Um, so how do I? Okay, so let's say there's some async function. So this is an asynchronous operation that's taking place. The moment it hits this asynchronous point, the moment it hits this point where it's calling this asynchronous function, it's going to return from this function back to whatever the calling function was, which in this case is the main function, right? And so once it returns back into the main function, you are free to do whatever other work in the main function, and just carry on with any other kind of work that you might have. And then eventually, once this async operation is completed, the program will automatically come back into this function and go all the way to the end of the function, and then it's going to exit out and carry on with your main function. That's usually how async programming works. That's usually how the async workflow works. And because of this, you are able to do a bunch of different operations without blocking the main thread because of async programming. But the thing is, all of this is happening on one thread. None of it is multi-threaded. It's all happening on the same thread. So if you do have something that's very intensive, very CPU intensive, you might want to consider offloading it to a different thread. If it's file IO, I've read that if it's IO related stuff, um, because IO it's more than just your CPU's uh, problem. Let's say it's more than just your CPU's responsibility. So you don't necessarily always see performance gains from offloading it to a different thread. You're better off using async. Though, if you're sure that whatever you are trying to do, like let's say you are sure that this amount of work that you have, even if it's IO related, this amount of work that you have, if you're sure that it's absolutely a lot of work, it's a very heavy load, then yeah, you can probably offload it to a different thread. To be fair, I guess it depends. I guess it depends because um, let's say you're writing data to a file, right? It's You're writing a bunch of data, but to one file. I think that can be done asynchronously. You don't necessarily need to switch to a different thread for that. But if you have a bunch of different files that you're trying to copy or something, I think then you could offload that to a different thread. So you can set up a thread that knows that it has to copy X number of files, and then you can just have that separate thread do that work. And once it's done with that work, then it can report back and say, okay, the work is done. So that way you free up your main thread to do other stuff. Either way, okay, let's see what Llama said. Okay, when dealing with file I/O in Python and considering whether to use asynchronous programming or multi-threading to improve performance, it's important to it's important to understand the differences and use cases for each approach. Async programming advantages. Async I/O allows your program to continue executing other tasks while waiting for I/O operations to complete, which can significantly improve performance and responsiveness, especially in I/O bound applications. It enables non-blocking I/O operations, meaning the program does not have to wait for the completion of one task before starting another. The async I Okay, that's yeah, I think that's what I've looked into. The async IO module in Python provides a straightforward and intuitive syntax for writing asynchronous code. How to implement. Use async IO to define functions, okay, and then await. File operations, you can use libraries like AIO files, which integrate well with async IO to perform asynchronous file IO. All right, okay, I'll look into AIO. AIO? Yeah, AIO files. Okay, good to know. Multi-threading advantages. Multi-threading can be useful for IO bound tasks because threads can run concurrently, allowing one thread to perform IO while another thread continues with other tasks. However, due to the global interpreter lock in Python, multi-threading may not provide significant performance improvements for CPU bound tasks. How to implement threading module to create threads that can no, use the threading module to create threads that can run concurrently. For file operations, you can define a function that reads or writes files and run this function in multiple threads. Example, so and so. Okay, choosing between async and multi-threading. Async await is ideal for I/O bound tasks where you need to perform multiple I/O operations concurrently without blocking the main thread. And it provides better performance and scalability due to non-blocking I/O operations. And it also has simplified syntax and better integration with other asynchronous libraries. Multi-threading, used for I/O bound tasks, but may not offer the same level of performance improvement as async await due to the GIL. It can be more complex to manage, especially with shared resources. And it's suitable when you need to integrate with existing asynchronous code or when working with libraries that do not support asynchronous operations. Okay, so there's a couple of things I need to look into. You know what? You know what I'm going to do? Okay, it seems like the program that I'm trying to build, the program itself, I need to sit down and figure out a good logic for it because there's a bit of system design that I have to do there. There's a bit of software design that I have to do there, um, just to figure out exactly what the program is supposed to do and what the flow is going to be like. And once I've decided that, then I can decide whether I want to use Python or Rust. Because, I mean, to be fair, there's a fair bit of other stuff that I'm going to be doing with Rust anyways. So, like, in terms of practicing Rust, I don't think this is my only option. This is my only opportunity to practice Rust because I'm going to be doing a ton of ML and data science and even ESP32 related stuff in Rust. So I'll get a fair bit of practice. But one of the main reasons I'm really leaning more towards Python, aside from the fact that I'm super comfortable with Python, is that string related stuff is just so much easier in Python. Like, I'm not even exaggerating when I say it's a lot less hectic. I should say that. It's a lot less hectic to do it in Python than it is to do it in Rust. You know what? Okay. Yeah. I'm deciding it here. I'm gonna do it in Python. Yeah, yeah. I'm gonna do it in Python. I'm gonna sit down and create the software design first. I need to write down what I want the software to do, what the workflow is gonna be like, what the features are gonna be, and then we can start working on the program itself. Yeah, yeah. This should be fun. This should be fun. Though I mean, I could offload certain things to um I could offload certain things to the to a different thread. I don't know. I don't know. We could still explore. I mean, I don't think I need to explore async. I just need to refresh my knowledge on async, and that's dude. That's one of the great things about async is that it is so simple. Look at the code here. Look at this. You define this async function, and then in your main function, you can await the async function, right? So it's gonna start this operation, which is whatever is going on in this function, but it's not gonna block the thread. It's gonna start this operation, and then while this operation completes, it's gonna carry on doing this. Actually, no, back up. I need to look into how it does stuff in Python. Because the moment you say await, that's when it actually. So okay, when you say await, it kind of returns back, but that's in C sharp. I need to refresh my knowledge on Python's async because in C sharp, when it hits the await point, if it's in an async function already, then it's going to jump back to the calling method. The moment it hits the await, it's going to jump back to the calling method. Yeah, yeah. Okay. So I'm gonna look into either way. My point was that yeah, this async stuff is super easy to set up in Python. I'm curious about multi-threading in Python. So at the very least, I want to try and explore it a little bit. Just learn like the basics of multi-threading in Python. I also want to learn multi-threading, both multi-threading and async in Rust, but not for this purpose. I want to learn multi-threading and async in Rust for ML related stuff. Okay, okay. All right. You know what? That's going to be it for now. I need to end the stream. Later on in the day, I'm going to start a data science lab stream. And yeah, yeah. So I hope you guys have a nice day, and I'll see you all next time. Peace.